Hello class, welcome to lesson 2.4b. Today we're going to take a look at simplifying rational expressions. Hopefully from last day's lesson or last day's work period you got a little bit more familiar with factoring. So let's take a look at this and try these warm-ups. So it says to factor where possible. In example A, it's simple trinomial factoring. In example B, this is decomposition. In example C, it is a difference of squares. In D, again, it's decomposition. However, I want to make a note of E. This is probably from your homework, which was page 102, 3C. This is a special type of factoring. We call this perfect squares. We really haven't reviewed that much. Basically, you could do the same, ladies and gentlemen, as doing decomposition. However, you will struggle to note that when you're looking for your factors, a product of 441 and a sum of negative 44, those are big numbers. I would try to do what's called the shortcut for this. Take the square root of the first term, take the square root of the last, and if the middle term is double that product, then you have it. Just remember, folks, when we start with, let me try my highlighter here. When we start with a binomial and we square it, remember we do square the first, double the product, square the last. It's the opposite. It's the square root of the first, half of the product, and square root of the last. Okay? So that's an easy way to recognize that you're going to have equal factors. Or, ladies and gentlemen, if you do decomposition and you realize that both of your factors are exactly the same, then you will know that you will have what's called a perfect square. So in this case, if you do decomposition and it's still fine, it just takes you a little longer to get to. Oops, sorry, too far. When you go to do decomposition, again, you split the middle term here, ladies and gentlemen. You group the first two terms and you factor by grouping. And you get 3x minus 7. You group the last two, you get 3x minus 7. But what you notice, folks, is the common factor is 3x minus 7. But your leftovers are also 3x minus 7. So make sure you state that both factors are the same, so you express it as 3x minus 7 all squared. All right, let's take a look now, ladies and gentlemen, at simplifying and evaluating rational expressions. Again, a rational number, which is a fancy name for a fraction, can be written as a over b, where b belongs to a set of integers. But remember, folks, b cannot equal 0. If you try plugging in your calculator 22 or 55, take your favorite number and divide by 0, you will get what's called an error in your calculator. Stay tuned for that, ladies and gentlemen, when we take a look at restrictions later on. Okay? What we're going to do, though, instead of having 2/3 as a fraction, is our numerator is going to be a function and our denominator is going to be a function. So a rational expression, instead of a rational number, can be written in the form of p at x over q at x. You could have f at x over g at x. But just remember, the same is true about a fraction. In order for this rational expression to exist, the denominator cannot equal 0 when we're dealing with polynomials. Okay? Let's take a look here at these two examples here. In example A, notice that there is a function on the top of a binomial divided by a monomial. In example 2, we've got a binomial divided by a trinomial. Let's now try to do some evaluations here and just do a quick substitution for x equals 3. So if we sub x equals 3 into the first expression, we sub in, replace x wherever you see an x, you put a 3. And then simplify that out, you'll know that you have 1 over 4. Where it gets tricky, ladies and gentlemen, is when we sub it into b part. And in b, again, we replace x with 3. But when we look at our denominator, it gets kind of confusing because 3 squared is 9 minus 3 minus 6 actually gives you a 0. And if you try to plug in your calculator, this is what we call undefined. So we don't want to have any function to be undefined, so what we do is we talk about restrictions. Okay? So in order to state restrictions, we basically let the denominator equal 0. And once we've solved for the variable in the denominator, that states our restriction. All right, let's try some of these examples. And next day or next class, ladies and gentlemen, we will discuss specifically why there are restrictions. And just to lead into the next lesson, some of these restrictions will be what's called a vertical asymptote, and the other ones will be what's called just a simple hole if we try to graph this function. Again, that'll make more sense once we do the graphing lesson, which is 2.5. But for now, let's just deal with getting these restrictions, because if we understand how to do the algebra of getting them, then next day's lesson will also be easier. So looking at our first example here in A, okay, again, we've got x divided by x plus 5. And remember, to find our restriction, the denominator, we set it equal to 0, okay? Because that tells us what we don't want it to be, right? Because if it's 0, then it's undefined. So we say x plus 5 cannot equal 0, and then we solve for x. So the positive 5 comes over and becomes a negative 5. When you have a variable by itself, it always can't be equal to 0. In C part, when you've got two binomials, remember, zero product property, either the first binomial could equal 0 or the second one. So just envision, ladies and gentlemen, having a trinomial here. We're going to factor like last couple days we've been doing, simple trinomial factoring. And then we're going to set each of those factors set to 0 and solve for each of them. If they're written accordingly, x plus or x minus, it's just going to be the opposite. So it says x minus 2 cannot equal 0. Move the negative 2 over, x equals 2. Think about it. How do you get this bracket to equal 0? It's got to be 2 minus 2 to give you 0. Second in bracket, x plus 6 equals 0. Move the 6 over, so x cannot equal negative 6. Looking at D, it's a little more complicated. Again, the denominator, set it equal to 0 and say that it can't be because it's a restriction. So we take a look. 3m equals negative 2. How do you get 3 by itself? Divide both sides by 3. So in this case, m cannot be equal to 2/3. Looking at example 3, now we're going to add one more part to this. We're going to simplify each rational expression, and then we're going to state the restriction. So there's two different parts to this question. You could be asked just to simplify a rational expression, or you could be asked just to state for the restrictions. However, be careful, ladies and gentlemen, if they ask you for the restrictions, you may need to simplify it in order to be able to see what they are. All right, so looking at the first example, what goes into both the numerator and the denominator, both can be divided by 2 and by x. So when we simplify that out, ladies and gentlemen, it's 1 over 4x, which means how do we get the denominator to be 0 to state a restriction? Remember, x cannot equal 0. In B part, both the numerator and the denominator can be divided by 9xy. What are we left over with? In this case, it simplifies to x equals 3x squared y divided by 1, or just 3x squared y. But, ladies and gentlemen, notice here, ladies and gentlemen, that there's no denominator anymore. But what you need to remember is you got to go back also to the original expression. And in this case, x cannot equal 0 and y cannot equal 0. We're going to learn tomorrow that when the variables cancel out, that's a special type of restriction versus when you simplify them and they still remain. Okay? So again, that's coming up tomorrow's lesson. So be excited for that, all right? I know math is so exciting, isn't it? Yay! All right, taking a look at example C. Look at the numerator here. What can we common factor out is an A. Look at the denominator. What can we factor out? A 3. Notice when we simplify, usually you're going to be canceling or reducing in some case. So what is canceled out, ladies and gentlemen, is the 2b minus c. So what are we left with when it's simplified is a divided by 3. Please note, ladies and gentlemen, that Although it's been canceled out, we still need to include it as part of our restriction. So b, sorry, my fault, 2b minus c cannot equal 0. So you move the negative c over. So your restriction here is 2b cannot equal c. All right, D. Taking a look at this example, a on the top we've got a minus 4, but on the denominator we have a trinomial. Simply do your factoring work on a side sheet of paper or a side margin, and then you come back and put down that a minus 4 times a minus 5. Look to cancel out. And again, in order to do your restrictions, you've got to look at all possible factors, even the ones that get canceled out. And again, that we'll learn tomorrow or next class what the difference is between a factor that gets canceled out and a factor that remains the same. So in this case, a cannot equal 5 and a cannot equal 4. All right, ladies and gentlemen, let's do a couple more here. Hang on with me, we're almost there. All right. Don't worry, we're not going to do G and H because the lesson would be way too long. So let's just look at E. E, ladies and gentlemen, hopefully you can recognize this as a perfect square. So you square root the first is 1, you square root the last, which is 3. 1 times 3 is 3, you double it, and you get your middle one. So that's going to be x plus 3 squared. Or again, you could have done simple trinomial factoring on a side sheet of paper. The denominator, ladies and gentlemen, it's simple trinomial where you're going to have x plus 3 and x minus 1. After we're done simplifying, we end up with x plus 3 over x plus 1. Again, look at all factors that are on the denominator when you're looking at restrictions. So x cannot equal negative 3 and x cannot equal negative 1. And again, tomorrow or next class, we will learn which one does which thing. Just to give you a heads up, when something cancels like this one, ladies and gentlemen, that means there's going to be a hole in our graph. But when you have an expression that remains, that means that's going to be a vertical asymptote. All right. Looking at F, this is a hard one, ladies and gentlemen. It's decomposition divided by decomposition. So again, you do your rough work on a side margin, okay? And make sure on a test that you show me that side margin, so just so I can give you part marks in case there is an error. And after you do decomposition, you look and you can cancel out. And so we're left with 3x minus 1 over 6x minus 1. So look at the denominator that exists as well as the denominator that got canceled. So x cannot equal negative 3 and x cannot equal 1/6. All right, so see why, ladies and gentlemen, the factoring part is important because it leads into the next couple of days' lessons. Okay, but today your homework is page 112, numbers 1 to 5, 10, and number 17 is a tricky one. Good luck with that, and again, please practice your factoring, and if you need some help, please come and see me.